So good afternoon and welcome to this revision. And yeah, so hopefully you got everything as it's supposed to be. So I tried to make my work easy. I used an Excel sheet, the formulas that you already know. So here, let's see. Hmm. So the first solution is just the equations. So these are the table of the asphalt content. So let's see the first the question first. The aggregate mix used for design of an asphalt mixture consists of 42% coarse aggregates, 51% fine aggregates, and 7% mineral fillers. If the respective bulk specific gravities of these materials are 2.60, 2.71, and 2.69, and the effective specific gravity of the aggregates is 2.82, determine the optimum asphalt content as percentage of the total mix. If results are obtained using Marshall stability method are shown in the table 1, the specific gravity of the asphalt is 1.02. Specifications are as shown in the table 2. So just like what we've done in class, um, just like what we've done in class, the this is from the Marshall stability: weight in air, weight in water, the stability value, and then the flow. So in this case, we only have maybe one measurement, but however, normally you do this 3 times. Remember the example we did in class, you do 3 times and you can find the average. And the limitations, usually we are concerned of the air voids ratio should be between 3 to 5%, okay? And the stability value. So the value that you choose, the content, the bitumen constant that you choose must, depending on whether you have light traffic, medium, or heavy, the value has to be between these values. And of course, the number of blows is the specification. If you decide now to implement, because once you decide your percentage, you mix and then test. So these are the recommended number of compaction blows. If now you decide now to continue, proceed with the test. Okay. So for this first question, if you remember, so maybe just to remind you, um, the this is just the series of equations basically from the notes. So it's easier on Excel sheet to not to make to it's you can just generate and then you make sure there's no error. You can reproduce many equations with very little um, so there's high level of reproducibility in Excel, so that you minimize errors than if you were calculating by hand. So just to show you in the Excel sheet here, so for example, all this data up to here have been provided. So starting from mg, um, so this is gmb. So let's see what that is. Gmb, how do we calculate that? So nothing really, just to see that you can remember or implement these formulas. So these ones you should remember off head. Okay. So GMB is weight in air over weight in water, weight in air over the weight in air minus the weight in water. So That's what I have done here. Weight in air is C2 over C2 minus weight in water. So then by so just dropping down the form, dropping down, then you can get the several calculations. Similarly, the bulk density, bulk density is in fact the specific density, but of course times so this is remember the units that we are working in are the pounds per cubic feet. So this is the 62.4 is the unit weight of water. So you must find the specific gravity, and then you multiply with the specific gravity of water. So how do you find the specific gravity? Just follow the the procedures already established. So the specific gravity, okay, we remember this, so we can follow here from here. Yeah, you find the average. So for this, you find the weight in air over the weight in water over the differences of the weight in over the differences of the weight in air and in water. So actually, yeah, actually this one is GMB times the specific. So you can see there's no difference. This part of the equation, is the same, is GMB. So GMB times the specific gravity. So nothing. So times 62.4, and then you convert. So and then you can see the magic of Excel. Once you write the formula provided is correct, then you can calculate all those at a go. So class rep, I hope you're seeing. Please confirm that you, yes. Okay. So and then the VMA. So these are just formulas that we have here. So VMA is so just try to reproduce this in Excel. You can do it manually, there is no problem, but of course you can see the magic of Excel, so making it easy. Okay, and so VMA is just 100 minus GMB. So we have GMB and GSB is the, so we need to calculate GSB first, and GSB is what now? Yeah, so GSB is here. So for different contents, so GSB is based on this as contents of the filler, fine aggregates, so filler, coarse aggregates, and okay, fine, I don't know, one of them is fine, coarse aggregates and fine aggregates. Okay, so when so these percentages are based on the overall. So the overall percent is 100. So here what we do, we subtract. So the percentages, these percentages, you can see now the cost aggregate we are told is 42%. So 40, you can see 42% of times 100 minus 5.5. So you can see the difference here now is 100 minus 6. Okay, so these percentages have been given to us: 42, 51, and 47%. So those ones have been provided in the question. So here, where is that? Here, 42, 51, and 7. So that's what you do. So once you find the difference, then you multiply. Okay, then the GSB is GSB can be calculated. So these formulas you need to remember. Yeah, so this is how to calculate the GSB. So the percentages, so added over the each percentage of each kind of aggregate, or whether be it fine or coarse or a filler, divided by the bulk. I mean the specific gravity of each of this. Okay, so here this is what we are doing. So you add the 8. So you add these ones, all these ones you add, which actually, if you think about it, it's just 100. All this is 100 minus 5, isn't it? My minus 5.5. So okay, so that's this formula. That's what we're implementing. Okay, so we in formulation. So this is the PCA plus PCPFA, and then PMF, then over each. So now this is PCA divided by the individual bulk density, which we have determined here, right? Okay, over I, no, not this one, over, or the specific, these ones we have been provided for us in the equation as well. So these are the bulk specific gravity is 2.6, 2.7, and so on. So over, you can see over, if you check, so this is PCA, PFAA, and PMF for the fine, and then this is the cos divided by the specific gravity, okay, of cos, and this is a fine over the specific gravity of fine, and percentage of filler over the specific gravity of the filler. So nothing strange, and you can see the values do not change that much. So actually you can use, for all intents and purposes, the value is more or less the same. So also you need to learn something. If you need to fix the formula, this is what you do. So please note, in Excel, if you want to fix, if you want, because if, for example, if here, if I am dropping if I drop like this, so I want you to see what will happen. So if I delete that, this if I delete that, if I drop, so it can calculate on its own. You can see what is happening. So that's the magic of Excel. But this way means that you can see here C2 over C2 times D2. So, and if we go here, we are talking about C3, D3, and so on, C4. So this is, if you don't put the hash, if you don't put this dollar sign, then Excel knows that you you move from C2, C3, C4, C5, and so on. So you take the inputs as the rows go down. However, if so here, if you don't put that, it will pick the C2 and D2, and so here also pick C3 and D3, and here pick C4 and D4, and so, because there is no dollar sign. Now if you put the dollar sign here, for example, then it means that value does not change. If you drop down, so let's say, okay, this is the enter, okay, that means that value will not be, it will not pick the way it has picked them before. So let's see. So if you do that, you can see the curve is even changing, but of importance, you can see C2 is fixed. the one that whose sign you have put is, you get it. So that's the idea. So because these values will be used in all equations, so that's why in this it's fixed, those values don't change. But for values that are changing, you don't put the dollar sign. So you remember we modified this one, so but that's not correct. I'll just trying to demonstrate. So we remove the dollar sign, and then our curve goes back to what it was, okay, the correct one. Then having determined that, then we know that so this is the formula for VMA. Where is that? Where is it? Okay, the formula for BMA is 100 minus GMB we have, there's percentages we have, and GSB now we also have. So now again, like I said, you can join, you can calculate by hand, but Excel would make it easy. So now we implement this. Okay, for example, this 100 minus this was GMB, so GMB times 100. So the percentage is just 100 minus each of this, 100 minus each of that, and divided by H9. So for the first one, the GMB is H9, isn't it? H9, okay, and here this would be H13, okay, and so and so on and so forth, okay, and so that's, these are the values we get. And then GMM, you know the formula for GMM. So I won't stress this enough. Please remember those formulas. No one is going to provide. Those formulas are simple enough that you should be able to remember. So GMM, okay, is 100 over the percentage divided by GSE, and then the percentage of bitumen over the specific gravity of bitumen. So the same thing, 100 divided by the percentage, okay. Why is this? Okay, yeah, this is the percentage of aggregates. So aggregates, just a minute, maybe. Yeah, percentage weight of aggregate. So aggregates are coarse and fine, remember that, coarse and fine aggregate. So those ones, because filler is making filler is 7%, that means coarse and filler is 7%, that means the others make 93% of the aggregates, okay. So that's what you see here, and you substitute, and you're able to make this kind of calculations. Then you get PA, so that's the percentage of air, the formula there. This is GMM, based on GMM and GMB and all those things you now have. So here, based on GMM is here, and GMB, then you can carry out your calculations, okay. Then you draw the curves that we know the 5 of them, so you can check. So for example, this is asphalt versus the bulk density, okay. Then the second one is asphalt content and stability, okay. The third one is the flow versus asphalt content, and the fourth one is the void percentage mineral void versus asphalt content, and finally the this content versus the air voids, okay, the percentage of air, the percentage air voids, okay, in the compacted mixture. So having done that, so this is just showing you the Excel sheet. So that's so once you do that, then you draw the curves, these curves of hours, and then you find the optimum. The optimum value from here is about 6.7, 6.8 from the bulk density curve. From the Marshall stability and asphalt, the maximum seems to be 6.5. The optimum here is 6.4 using the VMA curves, okay. So once you do this, these are the curves that we use. If you remember the example that we had done in class, then you find the average. So here I think this is 6.8, this is 6.5, and this is 6.4. Okay, so okay, there's some allowance, depends on your own the way you estimate. Of course there's some allowance. And then so from 685 from the bulk density curve, from Marshall stability is about 6.5, from VMA 6.4, then you find the average 6.58, okay. So if 6.58, then you go back to the curves and see 6.58, where do we place 6? This is 6.5, 6.5, and this I think 6 point, these are how many? 0.1 I believe. So 6.7, 6, each one of these is 6 point, so this would be 6.6. So 580 somewhere there, and then you read the bulk density, okay, and then come here and read 6.58, maybe somewhere there slightly, and then you read the Marshall stability. So those are the properties that you need. So here is about I think 155.6 lb per feet cubed. This one is about 1860, and 6.58 here is about 16 I believe, is about 16, and 6.58 is somewhere slightly there, about 12.4 or something, 12.4, and 6.58 I don't know, maybe I'm not sure, 6 point somewhere there, it should be 2 point something. Okay, so now let's see. Once you read 155.6, as you've seen, 18.60, okay, this is 16. The percentage void seems very low, 6 point, let's see. Okay, let's try to erase it. So 6.5 is somewhere there, okay. Yeah, you can see it's very low, 6 point, so 6 point somewhere there, so about 1.6 or 1, yeah, okay. So this is 1.6, where is that? 1.6, okay, and percent VMA is 12.4, so you've seen this. So this is not okay, you can see not okay, because the limit, we are told that the void ratio should be 3 to 5 for all of them, and ours we are getting 1.6, which is very low. Okay, now question, an interesting question you'll be asked. What can you do to cure this? Everything okay. Okay, so the void is not okay. The flow is okay because you can see here 1800 for heavy traffic, but we are getting 1860, so it's okay. Around 1800 is okay. Anyway, we don't know which kind of traffic it is, but we assume from the value that we can see it's closest to 1800, so which is okay. Okay. So this is the only thing we need to check. The void ratio is not okay. Go to your notes. What did we say? When stability is okay, but the voids are too low. Yes, yes, class rep. Yes, yes, yes. So that is a question I can ask you once you comment on your answer, and that's the kind of comment I'm looking for. For example, okay. So when no, okay, your answer is correct, class rep, but you need to check whether the aggregates, the voids are too low, but is it stable? Is the stability okay? Because the remedies are different. If the stability is not okay and the voids are too low, something else. If the stability is okay and the voids are too low, there's a section we talked about how to deal with whatever outcome that you have. Okay. So that solves this question one. That is the only question someone would say was challenging. Unless there's a question. Yes. Mhm. You can redesign, yes, you allowed, because the maximum, what do you mean satisfactory? The maximum, the asphalt content is not the controlling factor. The factor is whether uh, in that mix the stability is okay, the voids ratio and so on. So even if you get that the content is no, normally, actually, yeah, the standards give a content of, I think, at least between 3, I think, to 5, something like this. That's the asphalt content. So what guides you within the range of the asphalt content that you have chosen? Check whether those requirements of the void ratio, the stability, and so on have been met according to the restrictions. So one what you can do in that case, I think you can redesign, you can readjust the values a little bit. Okay. Yes. So I think that solves the that part. So did you get any answers closer to what I have found? Hello? Sorry? Okay, I didn't hear, but this is what you need to follow. The So this is you remember the remedies. So if we have low voids and low stability in this situation, the voids in the mineral aggregates can be increased by adding more coarse aggregates. Alternatively, the asphalt content can be reduced, but if only the asphalt content is higher than normal used and the excess is not required as a replacement for the amount absorbed by the aggregates. Care should be taken when the asphalt content is reduced, because this can lead to both decrease in durability and an increase in permeability of the pavement. Okay. So and then we have low voids ratio and satisfactory stability. So that's our case, our very case. This mix can cause reorientation of particles and the additional compaction of the pavement with time, as continued traffic is imposed on the pavement. This in turn may lead to instability or flashing of the pavement. Mixes with low void should be altered by adding more aggregates. Okay, so any once you do your mix design, if you find any anomaly, unless it passes all the checks, but if it doesn't, you can check what is ailing you and find the solution here. High voids ratio and satisfactory stability. When voids are high, it is likely that the permeability of the pavement also will be high, which will allow water and air to circulate through the pavement and result in premature hardening of the asphalt. High voids should be reduced to acceptable limits. Even though the stability is satisfactory, this can be achieved by increasing the amount of mineral dust filler in the mix. Okay, so you add fillers. Satisfactory voids and low stability. This condition suggests low quality aggregates, so you need to change the quality of the aggregates. High voids and low stability. It may be necessary to carry out two steps in this case. The first step is to adjust the voids as discussed earlier. If this adjustment does not simultaneously improve the stability, the second step is to consider the improvement of aggregate quality. Okay, so if you read the notes, you should be fine, so to speak. So any question about question one? Any issue? Okay, so we move to the next one. So that is probably the only question we would say challenging. The rest is is easy. So the latitude of location where rural high-speed road is to be constructed is 35 degrees. The expected equivalent axle is 32. The 7-day average high air temperature is 53 degrees and the low air temperature is negative 18 degrees centigrade. If the standard deviations for high and low temperatures are plus minus 2 degrees centigrade and plus minus 1 respectively, and the depth of the pavement is 155 millimeter, determine the appropriate asphalt binder for this project for reliability of 98%. Okay, so here nothing major, we are just using a table. So this formula, you know, okay, how to get the T20. So you just substitute in the formula. I'm getting figure of 73.51. Okay, so and then you get T pavement again. This formula is from the notes. I get negative 6.74, and then you just go to the table to see the table 18.11. So these formulas, this is what you need. So 18.11, so 7610. So for 50% reliability, so first of all, the ESL is greater than 30. Remember from the notes, so I need to point to you here. For equivalent single axle, see for definition, so of between 10,000 to 30, you should consider shifting the binder based on the procedure of one temperature binder grade. But for Excel, you must, so between 10 to 30 you can consider or leave it where what you find. For this you have to adjust. So for this one, based on the temperatures that we found, so these are 73 and negative 6.74. So if you go to table 18, the table 18.11, what will fit this bill is 7610. So here, that's the binder, but this is for 50% reliability, because you can see the equivalent single axle load is greater than 30. So if you choose this one, that is 50% reliability. For 98% reliability, you need to go one grade higher. So one grade higher, if you go to this table, 7610 is here. 7610 is here. One grade higher is 7616. Okay. Sorry. Yes. So for 50% reliability, that is 7610. Okay. But for sorry, you don't move like this, you move this way. I'm sorry, this way. So for one grade higher is 82, because the grade is 7610, but you need to go one grade higher, which is 8210, and this is for 98% reliability. So this is 50% reliability, 7610. For 98% reliability, use 8210. You correct one grade higher because of the equivalent single axle loading. Okay. So now we need to determine 7-day maximum temperature for 98% reliability. So this is just for the selection. Okay. So we have used the ordinary temperature to select the pavement. So for 50% reliability, 7610, we have corrected for the loading. So that is 8210. Okay. But remember, there is also the issue that the temperature can vary. So the issue with the 7-day minimum or maximum temperature. So you also need to consider this. So determine 7-day maximum temperature for 98% reliability with standard deviation plus or minus 2 for high temperature, plus or minus 1 for low temperature. So for high temperature, if you do that, we can get 57. We're interested in the highest. And if you calculate T20, the T20 is 77.3 degrees. And for the pavement, the value is, so usually you only are interested in the maximum, because this T pavement, you can see, is lower, this was negative 6.7. So just to demonstrate, otherwise from experience it should not, you should not calculate it. I just did this to demonstrate to you. So you can see it's encompassed inside this value there. And so now, so with this new correction in mind, in fact the correct one is 82, because if you check this table, 77 fits only here. 77 degree can only fit here. These values are lower than 77. Okay, so 77 will fit there, and hence the choice of so from that table, use 8210. Okay, so if this is the correct choice, then so now these are just hypotheticals. Okay, so 8210, and you can see it agrees with the correction for once we have corrected for temperature, I mean for traffic loading. But hypotheticals, but because this is also a revision, so this is for slow moving traffic. If this is the grade that we ended up with, 7610 initially from this selection. So we have chosen, so for this case the answer is 8210. Okay, so hypothetically speaking, if we were talking about, for example, slow moving, traffic. For slow moving traffic, you must uh, you must you must take it one grade lower for 50% reliability, and one grade higher for 98% reliability. If you're talking about slow, so for slow moving traffic, for example, 7610 is here. Okay, 7610 is there. So for slow moving traffic, you have to take it one grade higher. Sorry, wait a minute. Yeah, one grade higher, which is 7616. That's for 98% reliability, and 7016. So one grade lower than. So this is what we found. If you want to upgrade it, one grade higher is 7616, and if you take it one grade higher, that means is we are looking for 98% reliability. Okay, and if you take it one grade lower, that is 7016, this is for 50% reliability. Okay, so if you were to correct for slow moving traffic, but this one is just a hypothetical and to demonstrate to you how the table is used. Okay, so the correct answer for this is 8210. That's the correct selection. I hope I've made myself clear. I remember someone was asking how to use the table. The table, is that clear? From my calculations, yes. I will get the value to be 8210 before like moving it a bit higher. So I don't have any other grade higher, so I have to stick with 8210. In that situation, it's not sure this stick to 8210 or less other. I don't know. Okay, maybe I don't know what 8% reliability. So for 90, so already for 98% reliability, we have been told is 5816, isn't it? This is what we have got for 98% reliability for slow moving traffic. So if you want to correct for 50% reliability, you go one grade lower. So just from this table, that's a hypothetical because that's not the question, and because this is class example, so you need to look at it from all dimensions. So here the grade is 5816. Where is that? 5816 is there. So one grade lower is 5216. So the one grade, this one is 90 because we already found it from the table 18.1 to that. This is for 98% reliability. So if you go one grade lower, that means you are talking about 50% reliability. Okay, and we don't need to correct because the table has been given to us. The traffic is not in the range that we need to correct, so nothing to worry you, just to read in the table. Okay, now this one also some calculations. So this one is the Superpave mix design. Nothing to worry you either because just the calculations that now you're fine with, or you should be at least. So we I have done it in the here number 4 here. So again, the formulas I've shown you on the right, and I've used Excel just to make it easy. So at 5.5%, the following. So these are the trials, and then we need to find the initial trial mix. So what was I doing here? So the different percentages have been given here. I'm not sure what is happening here. Okay, so these are the so first you need to choose a range of the asphalt content that you need. I don't seem to understand what I was doing here. Have I used that anywhere? 0.95, okay. So these ones have different based on the mix. They have different effective specific gravity and different bulk gravities, and then we have some mix different mixes of coarse, fine, aggregates, and filler. So these same formulas that we have, C6. So this one you can have different volumes. So just the formulas we have here, based on different trial mixes and the volume of aggregates, and based on different. So these are this is what we need to design VBA. Okay, and VBA depends on different values of VA, and of course the different percentage of aggregate, and the ratio of the specific gravity. Okay, so then you, based on all these these values that have been provided here and there, you can calculate different trial values. That's the point, because for each trial this value will be different, because all the components are different based on the table. So this is what I did in the there. Okay, and so you have different values of VBA because for different mixes will give you different values. Okay, and then you calculate the GMB based on the formulas that I've shown you, and then you get different values of PBI as well. This is what we are supposed to design actually. So 8.1, so these are the values, okay. And but if I checked the value of VMA, VMA should be, if for this VMA should be the Superpave. Anyone remembers, are those values good? Class rep, we have been told that this is the normal, the nominal size is 19, and there's a table that is we are supposed to check. So 9, where is that table 9? Yes, for voids, for nominal size 19, the voids ratio should be 13. But you can see from our trial mix, the VMAs are very low. So these ones are not okay. But you are just told to, because you know you have already been fixed. What you can do is very little, because the these ratios, the effective specific gravity is already fixed, the bulk density is already fixed by the mixed, the percentages are fixed, okay. So there's very little you can do. All is you can take those values and calculate and see what value of the binder content that you can get, but you don't step there because there is a limit. So we get from these different values, we get 8.1, 8.11, 8.0, around the same value, but you need to check whether the volume mineral aggregate is okay, which we can find that is very low, okay. Again, so if this is low, you go to the remedy. So this is not okay, you have to redesign this. You have to play around with the mixes a little bit, especially the aggregate and the binder content. Go and read the remedies that we talked about previously, and see. So with this, you have to retry, change, rethink the mix, change the percentages, and see whether you are getting the values within the limits that have been given to you. So for this one, just use the formulas, get different values, and check whether they really are within the limit that we need to have. Yes, someone have raised their hand. Who is this? No, my friend, you are an engineer. Someone is up in arms saying you are not. Yes, but you are designing something that is going to be used. So you must check whether it is within it is satisfying the conditions. Because otherwise, if you just mix, your calculations are giving you, and then you go, you put it out there and it won't last, then what one would wonder what kind of an engineer. So you must check that it obeys the limits. It's true you are not asked to check the void, but you must check as a designer, because if you want to use it in the field, you must ensure that it is within the limits, okay. So in this case, those limits are not okay. You just need to think of the entire design and recalculate the values and see. Once you change the aggregate and the contents, and see whether, so this, if you were to implement this design, that is okay. So far now, for the case of this class, because the question was just asking you to get the contents, so once you are able to calculate, you are okay. But I expect you at least to tell me that those limits are not okay, so you redesign. So okay, of course, if you are able to calculate the values, you are to reach the binder content, the three of them, then of course you have some marks, okay. But of course, when you are looking for that thing, that extra thing, so as an engineer, again, you need to check that your solutions, because actually I always have said in this class that garbage in, garbage out, whatever you input in a formula, you are going to get a solution, okay. So at the end of it, you have to check whether the solution makes sense or not. Okay, that is what sets you apart. So class rep is there in